And what I'm going to talk about, I hope, will also invigorate some new ways of conducting our research, and that is to talk about technology-assisted lie detection. Why technology? Well, sometimes we have to make this argument to the humans who are strong believers in the human judgment process. We all know that humans, even when trained, are often poor at detecting and highly variable in their accuracy. By contrast, if we rely on machines, we don't have the problem of them suffering fatigue or boredom or inattention or other kinds of distractions. And the new technologies can now allow us to detect things at a much more microscopic level and also get at some really fine-grained dynamics that are simply not detectable by the human. And we can also look at relationships among features. And finally, of course, we're now really harnessing all of this fabulous computational power to do these things many times in real time or near real time. Just to give you a little bit of evidence of the difference, from the mock crime experiment that I spoke about previously, we had 4 different interviewers, and for those of you who are familiar with receiver operating curves, they give you an idea of how well your judgment processes are functioning relative to chance. And if you will look at this graph on the right, those 4 different lines represent our 4 different interviewers, widely different in their ability. The closer they get to that middle line, the more they are simply operating almost on chance. And so one interviewer was fabulous, the next 2 okay, and the last one, we might as well have flipped a coin. So our guiding premise for wanting to develop more of this technology is we know, as we've all said, there are no deterministic behaviors that always indicate lying or that all liars will exhibit. And many of the correlates with deception stem from a variety of causes. So it's a multi-causal model. We've got cognitive load, memory access, emotional arousal, as well as strategic activity. Non-deceivers may also exhibit some of the same behaviors, and that's going to add a lot of noise to our system, especially if they're fearful of being wrongly accused. And finally, and this from a communication perspective is sort of a common assumption that humans are also strategic, and they do a variety of things. They're not passive, they are active participants in the process, and they will construct their language, their nonverbal behaviors, and so on to maximize their effectiveness. So for us, in looking at possible technology assists, we wanted to develop things that are non-contact, and so our goals were to come up with things that are unobtrusive, that could also be used obtrusively, because sometimes that's an excellent prop. Polygraph examiners also like to have the machines there because people can be intimidated. For instance, the story about the people who told somebody to put their hand on the Xerox machine, and then out came a statement that said false, and the guy said, "You're not fooling me with that. I used to sell that same model." So sometimes the props work, sometimes not. But we're also interested in coming up with multimodal approaches, because we don't believe any single sensor is going to be particularly completely reliable. We would like to be able to move to real-time and remote analysis, something that can be scalable, robust for high traffic, such as security screening, useful across contexts. So we believe strongly that things are context dependent, but there may be some features that are more context independent. And finally, something, easy to learn and use, so there's a shallow learning curve for the users. Some of the things that have driven our own work, we're trying to look at psychophysiological and behavioral features that are reliable indicators of deception, impostorship, fraud, and malice intent. The technologies we are hoping to find are the ones that are most effective for measuring and tracking these kinds of features. And here I'm going to talk most about some that we think have pretty good reliability and good discrimination ability. Some of the technologies we've used are depicted here in the screen. I'm not going to talk about all of these because we don't have the time. But we are especially interested in not only detecting things that we have called, and you've seen this graph before in Aaron's presentation, some non-strategic kinds of indicators, those that are arousal-based, emotion-based, and memory-based, but also things that people do thoughtfully, deliberately, things that they could rehearse or monitor, and these are the more strategic aspects of behavior that we would like to pick up on. Psychophysiological measurement, the kinds of things that go into the polygraph, EEG, fMRI, and so on, I won't have time to cover here, but certainly these are an important part of the overall mix. So let me talk a little bit about non-contact behavioral measures. We have been interested in things like skin blob analysis, and you heard a little bit about this before, where the computer vision imaging techniques can identify the hands, the head, the body, track these, and then we can get measures of the XY axes of the ellipses that are formed, and then look at the relationships among these features. We've looked at active shape modeling analysis, where you can put up to 78 landmarks on the face and identify the movements with those. Micro-expression analysis, specific feature analysis, things like voice analysis, and I won't talk today about the force platform, but that also will pick up on postural changes. So we've been hearing quite a bit about linguistic analysis. I want to tell you a little more about some of the work we do on linguistic analysis, and that includes looking at the lexicon, the syntax, morphemic clauses, collocations of words, lexical bundles. So it doesn't end up being just individual words. So those of you who are familiar with Luke, which is dictionary-based, it's got a wonderful set of individual dictionaries. We're attempting to go beyond dictionaries and pick up things that are more syntactic and that could look at combinations of words. These things operate independently of the message meaning, and so they can be conducted automatically. We can also do other kinds of message feature mining, looking at combinations of features, so you can form some complex algorithms with these features. Speech act profiling I won't talk about, but it's a different approach where you are identifying the different kinds of dialogic acts that people engage in and how those relate to one another. And it's a fascinating area, but we don't have time to go into it. And then sentiment analysis, picking up on the ways in which the language suggests the level of positive or negative regard in a piece of text. We've developed a tool at Arizona. Its precursor was Agent 99 Analyzer, which you heard mentioned previously. It's morphed now into Splice. And the architecture is such, this is a web-based client now. And you can put in a piece of text, go through the web server. It will give you output that looks like this. So you identify which cues on the analysis side that you want to have analyzed. It could be things like the number of characters, the number of words, amount of punctuation, presence of nouns, emotiveness ratios, and so on. And then it'll give you output for your various forms of text. And we have found this to be quite helpful in going far deeper than simply the dictionary-based analysis. This is too small intentionally for you to read, but what I want you to see from just one of our studies where we were looking at financial fraud, if you look at the column that's labeled results, I don't know, is this even, this is probably not plugged in, Sophie. Okay, I don't need the pointer, that's okay. See the column that says results, and it says F versus N, so fraudulent versus, okay, good. Yeah, fraudulent versus non-fraudulent. You'll see down this column, all of these features that have asterisks had significant differences, some of them whoppingly significant differences in everything from affect terminology, complexity of the language, the diversity of the language, the amount of expressiveness, a number of quantity measures, measures of specificity which pick up on details. And so there are many different things that are available out of linguistic analysis and pretty reliable. Now, that's one area that I think we've got a lot of presentations here that have demonstrated that this is a very promising direction. Another area, thank you so much, another area that's quite important to look at now, and with the advent of much better eye trackers, we can look at oculometrics. These are eye tracking devices that can pick up on pupillometry, such as the dilation or constriction of pupils. Eye movement, so if you put an image on a screen, For instance, you're trying to determine if someone's an imposter, and you put up their identification and you ask them to check the details on it to see where their eyes go. So their saccades and their fixations while viewing images. We can look at gaze direction either toward the screen or toward people. We've done something with startle eye blink modulation, and you blast people before they answer a question with a startling sound, and the intensity of their response turns out to be sensitive to deception versus truth. We've also looked at blinking, the spontaneous frequency, and the patterning of eye closures, and found, for example, if you measure it at 250 frames per second, you actually can find a bimodal distribution of blinks where a person will have a bit of rapid blinking and then a cessation of blinking and then a rapid blinking at the end. So the level of the granularity of the measurement is really key here. Give you an idea of some sample blink results. This is just regular blinking. We found our deceivers blinked more than truth tellers on 16 of 24 crime-relevant questions. So now obviously not all questions produce the same results. We got accuracies up to 90% in detecting deception or intense affective cognitive responses, more emotionally charged kinds of questions. And far less differentiation with low arousal, low cognitive effort questions. Here's again another pitch for why we need more high-stakes situations, ones in which people do have a stronger reaction. And the patterns here were strongly influenced not only by question, which recurs in our results every study we've been doing, but also by the interviewer, another pitch for looking at things dyadically. So, another area of analysis, kinesic analysis. This includes the face, the head, facial expressions, posture, gesture, gait, anything having to do with body movement. And here we've looked at both things at a more gross level, at a distance, so you get gestures and postures, and also then much more fine-grained when you're looking at the face. And then posture graphics, where you can do this unobtrusively, having people stand on a forced platform and they don't even know you're measuring their sway, their movement, the intensity of their pressure. To give you an idea of some of the skin blob tracking, you'll see here again what the computer vision technology does is it locates the head, the face, the hands, the limbs, and then we get measures. These were done at 30 frames per second. We've been up to as much as 250 frames per second. And so it finds these regions. You can then calculate a variety of things. We, for instance, calculated distances between the hands, the hand to head. Found a lot of face to, or hand to face gestures that people do that were detectable in this fashion. Some of our kinesic results, I presented a little bit of this in my talk yesterday. What was interesting is that if you take any one of these measures, they are pretty feeble, and they would support the idea that we just can't find reliable indicators. But when we, in fact, put the indicators together, we not only got this result, which I showed yesterday during a deception phase of the interview, consistent differences across questions between the truth tellers and the deceivers, but it also happened during the truthful phase. In other words, we were picking up on anticipatory behavior that we had not even expected to occur. So this is one of the virtues, again, of some things that can be picked up with this technology. The face tracker using the active shape model. We now have the capacity of picking up facial location, size, movement, and so on from 90 degrees to one side all the way to 90 degrees to the other. It used to be you had to have direct facial capture. That's not required anymore. So we have very robust tracking capacity here, and also can handle, as you've already seen, different skin colors. A lot of capacity now with, and especially as people have gone to 3D capture. To give you an idea of, again, some of the emotion tracking that you might see using this methodology. You'll see the tracking is on the right and his face without the dots on him above, and then getting an output moment by moment as to what emotion is being expressed. And you'll see up here in this upper quadrant, if you can see that. This is also picking up the head tilt, roll, and yaw, so you can also get your measurement of head. Much better than having humans try to watch it and do it manually. Okay, to give you an idea how well some of this can work, in one of our studies, the one I talked about yesterday that was mock theft, we were able, using the kinesic features alone, to get 94% accuracy identifying innocent individuals and 100% accuracy identifying guilties. In another study we did where we had people smuggling a bomb, just with two features, gaze duration and pupil diameter, we identified 88% of the people correctly, and that's including identifying all 20 of those who were carrying the bomb and 16 of those who were in the control group. So these become pretty powerful tools for picking up on changes in movement, and they suggest it's too early to give up on the kinesic behaviors. Okay, let me move to vocal measurement. I'm not going to go into much depth here because this requires a lot of extended discussion, but there are many, many features in the voice that can be calculated with Pratt and with some customized signal processing software. So you can pick up on frequency features, amplitude that has to do with loudness, tempo features, resonance, response latencies, pauses, non-fluencies. And we have found, again, with only a few features being measured, some pretty powerful discrimination. We did a security screening study, and here again, we had some people who were posing as terrorists and some who were innocents, and we ended up with a true positive rate, that's the TPR, of 100%, true negative rate of 79%, false positives, 20%, false negatives, 0, for overall accuracy of 81%. And this, again, was just with a few features with pitch and voice quality. So then in our mock crime experiment, we threw together, to do a multimodal approach, a number of kinesic and vocal features, and I won't go into the individuals, just to point out that there are quite a few features that were predictive. And not ones that the human would pick up on. For instance, you're not going to notice exactly where the left hand is positioned. Okay? These I put up only for you just to watch the dots, because the point is that we get, these are accuracies, ranging from 0 all the way to 100%. And for eye tracker, for instance, we might be in the 70s. For fused eye tracker with laser Doppler vibrometry, we might get better results. But the big story here is it's really variable. Some of the linguistic features were very strong. Some of the kinesic features very strong. Others, no. And so the accuracy rates are highly variable here, and one of the things we need to do really is work on finding the best combination of features put together in clusters, not individual features, but combination of features. So our conclusions: automated technologies can yield, on average, higher detection accuracies than the humans. The most promising technologies we have found so far in a number of studies: the psychophysiological changes in oculometrics, especially the pupil dilations, the blink and startle blinks; the posturographics, which I didn't talk about, but that's turning out to be, I think, very informative; the nonverbal behaviors using the computer vision techniques for kinesic analysis; certain sensors, certain algorithms for voice analysis; and then, depending on the study, linguistics has also been quite powerful. But a really strong caveat: things differ by question, so it's really important for us to identify which kinds of questions do give us diagnostic information, which kinds of questions just introduce noise. And, as you have heard us say, a centrally important moderator for all of this is culture, and I would say culture and context. So, we're doing questions later. Okay? Thank you.